Good morning, everyone. I hope you're doing okay. My name is Ilas Tamush, and together we're gonna present our work entitled "Machine Modeling the Academic Impact of Early ICT Exposure: A Cross-National Study Using Pooled Variance Optimization." This study explores whether early digital exposure helps or hinders academic performance across different socioeconomic contexts. Let me walk you through the plan for this presentation. I will begin with an introduction and a literature review, then present the data and methodology, followed by results and discussion. I will also cover the challenges and limitations before concluding with future work and implication. Children today are often called digital natives due to their early exposure to technology. However, this access is not equal, and socioeconomic disparities create a digital divide. Our study uses PISA 2018 data from 80 OECD countries to investigate whether early use of digital devices improve academic success in reading, mathematics, and in science. Our workflow starts with identifying environmental factors that shape the impact of ICT. Then we test whether age of first access to ICT matters for performance, while also considering socioeconomic context. Finally, we evaluate cross-national variation to see how countries' conditions influence the results. Our main objectives are threefold. First, to assess the impact of ICT access on student performance in reading, math, and science. Second, to apply a pooled variance t-test to compare a group based on exposure age. And third, to analyze variation across countries with different economic and educational profile. We also aim to explore the statistical methods themselves. In particular, we use pooled variance analysis to reduce bias in international comparison. We also address the challenges of data disparities across OECD countries. This ensures our findings are both statistically relevant and contextually relevant. The data came from PISA 2018, covering 15 years old students. Our dependent variable is academic performance, measured by plausible values in reading, math, and science. The key independent variable are the age of digital device use. The combination allows us to test the effect of early exposure in a robust way. To prepare the dataset, first we cleaned missing responses. Then we standardized the wealth index to compare students from similar socioeconomic levels. And the last thing is we handled data gaps from countries with uneven socioeconomic condition. Three steps ensure fairness in our international comparison. As for the methodology, we used pooled variance t-test to compare two groups. The first one is students who are exposed to ICT before age of 6 and those exposed later. The null hypothesis states that early exposed students perform worse, while the alternative suggests their performance is equal or better. This approach balances statistical rigor and interpretability. The model focuses on comparing average across scores in reading, math, and science across these two groups. By applying the pooled variance test, we obtain the balanced estimate of the variance and a stronger statistical basis for cross-country comparison. This helps us to ensure that our results are not biased by different sample size. As I already said, our dependent variable is student performance, measured through PISA plausible values in reading, math, and science. The independent variable is the age of first digital device use. grouped into early exposure versus later exposure. This simple design allows us to focus directly on the timing of ICT access. The result, we can see that the pooled variance test gave a t-value of 7.33 with a p-value under 0.001, rejecting the null hypothesis. This means students exposed to ICT before age of 6 perform at least as well and often better than those exposed later. The effect size is modest but meaningful, showing a consistent academic benefit. But despite these results, there are limitations. PISA data does not allow for all statistical check, like Leven's test for equal variance. The analysis is correlational but not causal, and socioeconomic variation is not partially controlled. So while our findings are strong, they should be interpreted with caution. These findings should suggest that investment in ICT infrastructure is essential. Early exposure work best in supportive environments, so policies must be context sensitive. A high-income country should focus on quality integration, while lower-income countries must first ensure equitable access and infrastructure. Future research should expand to more countries and newer PISA datasets, including detailed data on home ICT access, and use predictive model ideally. Experimental or longitudinal design could clarify causality and guide us to policies that will reduce the digital divide. Thank you for your attention. I'm happy to answer all of your questions. If there are any suggestions, I will be happy to hear them as well in order to further improve my research.